Hope it's visible.
Yes. Yeah, it's visible.
Okay. So let me know
We'll
once
start.
when to
Yes.
start. Yeah.
Yes, we'll start within 10 minutes, sir.
Yeah. Okay.
Yes.
Yeah. Good afternoon to one and all. I am Mrs. Vaishali Kulkarni. Welcome eminent personality, our today's speaker, Dr. Bhushan Garware sir, and all the other participants to the first session of AICT sponsored 2 weeks online faculty development program on artificial intelligence and its applications in biomedical engineering. It's my great privilege to introduce today's speaker, Dr. Bhushan Garware sir. Sir is currently working in a data practice group at Persistent System Limited, Pune. He is, excuse, he is a proficient data scientist with more than 6 years of experience in machine learning, pattern recognition, artificial neural network, data analytics, signal and image processing. Bhushan sir has his expertise in theory and principles of machine learning, teaching the same at corporates, research institutes and universities, and strong mathematical background of statistics, probability and time series analysis. Sir has pursued his PhD in Faculty of Technology, University of Pune, with Best PhD Thesis Gold Medal recipient of University of Pune and Master of Technology, College of Engineering, Pune. He was visiting professor in Vishwakarma Institute of Technology, VIT, Pune. Sir has handled many projects related to machine learning, to name a few: customer membership status prediction, anomaly detection in multimedia viewership data, and deep learning projects like digital pathology image analysis, CCTV-based face recognition for remote surveillance. Sir has to his credit the India's most prestigious and world's largest biometric project Aadhaar. Sir was the speaker for various programs like Essentials of Machine Learning, tutorial session at Compute 9th Annual ACM India Conference, Ahmedabad, 2 days hands-on workshop on machine learning at Data Intensive Science Workshop, Inter-University Center for Astronomy and Astrophysics, Engineering Faculty Development Program organized by University Grant Commission, and hands-on machine learning workshop for graduate students. Sir has one Indian patent in method for standardizing the fingerprint images in biometric recognition system, which is published in 2015, and one Indian and US patent in method and a system for matching fingerprint images obtained from different fingerprint image capturing devices, which was issued and published in the year 2016. We welcome you, sir. So it's a great privilege to have you today for our first session. So may I now request Dr. Bhushan Garware, sir, to take over the session. Over to you, sir.
Thank you so much for your kind introduction. I hope I'm clearly audible.
Yes, sir.
Yes. So thank you so much for inviting me for taking the first session of this 2 weeks faculty development program. I would like to, I consider this as a very responsible session, because the first session has to be encouraging for all the participants to, be there for the 2 weeks. I understand conducting online training is difficult, so I'll try to keep it as energetic as I can. We can have Q&As at the last part. So let me finish the contents. If you have any questions, kindly park it. And then at the end of this session, we will discuss on that. So with that, let me get started with introduction to AI. AI is a huge field, and it's, to be very frank, it's unfair to give you what AI is all about in 1.5 hours, but I'll try my level best to cover that. So let's get started. So if you see currently the trend in industry as well as in academia, everyone is trying to invent something new. Everyone is running behind invention. But it's very important that what kind of invention that you are doing. That means that somebody invented will, but somebody invented parking tickets. Now, if you see that the one who invented will and the one who invented parking tickets, who is earning more? So if you see all the innovations which is happening right now in industry, it is mostly money driven. But while doing an invention, it is very important to see what is an impact of that invention. And AI will give you a huge opportunity to come up with a very interesting applications and innovations which will change the world. So this question when asked, because in one of the talk, Bill Gates had said that AI has a potential of building 10 Microsofts. So a person who is learning an AI, if he comes with a breakthrough or path-breaking idea, you have a potential to earn the money which is worth 10 Microsofts. But while doing that, it is very important to understand what is an impact of your invention. So when this question was asked to Bill Gates, according to you, what could be the next big thing? Then he said that the next big invention that would change the way we live is the ways of generating energy like electricity. So tomorrow, if you want to come up with something new, it should have that potential like an electricity. In another talk, why electricity is important, because you'll see that it was invented in 1879, but this is a situation of today's, right? So invention could be very small, but we'll see the impact of that. Today we cannot think our life without an electricity, right? So the same question when asked to distinguished professor Dr. Andrew Ng from Stanford University, he said that AI is new electricity. And why he calls AI as a new electricity? Because in 2020, we have already seen applications of AI in a variety of domains. If you see, people are using AI for building constructions, AI is used for security, AI is used in marketing, smart home appliances, IoT devices, AI in healthcare, AI in remote monitoring, customer recommendations, smart grids, smart solar systems, industrial applications, manufacturing, and smart cars. So AI is finding all its application in various domains. So today, that is 2020, could be an year of invention of new things. But there would be a time where you will find that AI would be an absolute necessity for this. Now, I'm not exaggerating at all. Tomorrow you can see that we can still live without AI. There is no problem. Why you are adding some new fancy things which may not be applicable here? But this is not the case. My question to you is, can you take your car to a new city without having Google Maps with you? Not, right? So we have already finding and applications of AI which are absolutely necessary for us. And that's why Andrew Ng is saying that it's a new electricity. Because today we are inventing, but after a few years, the next, we don't have to even wait for next generation. Few years, we will find that it is an essential part of our life. And that's why it is very important to learn AI and to understand what AI is all about. And the good thing is that we are right now at the curve where technology is evolving. So this is the right time to learn AI and just ride on this wave and design amazing applications for humanity. If you ask me, is this a new term? Not really. AI is a very old term. So if you see this, the term AI was first taught in 1950 in one of the mathematical conferences. You won't imagine that, but that's true. And then it was an era of artificial intelligence from 1950 to 1980s. Unfortunately, algorithms were ready, but we were not having sufficient compute with us. So people had neural networks and all exciting algorithms which are ready on paper, but the real power of AI couldn't be seen at that time because we were not having enough compute with us. And then the lighter version of that, machine learning, support vector machine, these kind of an algorithms, they start taking gear up. And then 1980 to 2010, they actually ruled the technology. Everybody was applying machine learning techniques and doing the things. 2010 is an era where something special happened and deep learning start becoming popular. Again, I'm saying that deep learning has its roots from AI. The things are not different. Algorithms were written in this era only. But the good thing is that now we have nice GPUs with us. Okay, and thanks to NVIDIA for making them available, and now Google Colab that everybody can use it freely. So now we have GPUs, and now 2010 onwards, it's a completely excitement and nice applications that we see of the deep learning stuff. But the question is, in many talk, what I saw is, people keep using AI, machine learning, deep learning terms loosely. It is very important for everybody of us to get very crystal clear understanding that what is an AI, what is machine learning, and what is deep learning. So that when you talk, you will talk very responsibly. You will not say that, when you are doing something like logistic regression, you will not go out and say that I'm doing AI. Okay, it's important to understand what you are doing, and that's why it's important to understand what's the difference between these things. So if you see that AI, machine learning, deep learning, eventually they all are the subfields of a big area called computer science. So the computer science has a goal of, automating the things. What eventually we want to do is to automate the stuff. So the study of automating algorithmic processes, and that too at a scale, is called computer science. So we all are, all are the students of computer science, and the final goal is to automate something. Now, where AI comes into the picture. So AI is a subfield of computer science. So while doing an automation, you should take care of these four things. Your algorithms should have ability to sense, should have ability to reason, should have ability to act, and very importantly, very important is adapt. How can your algorithm adapt themselves while doing an automation? So AI is a subfield of computer science which has to sense, reason, act, and adapt. There is a small field of artificial intelligence that is called as a machine learning, which actually requires algorithms whose performance improve as they export to more and more data. Machine learning algorithms need explicit training data. And it's a small part of an AI. General AI is something different where you don't have to explicitly provide a training data. You don't teach your child by giving some training data sets, right? It learns on its own. So machine learning is a sub part of AI where you have a good amount of a training data, and then you find the automation, what machine does it. And there is a very interesting stuff in this machine learning algorithms. So on an x-axis, you have a data, and on a y-axis, you have a performance of your algorithm. One of the reasons why deep learning become popular is because of this. Machine learning algorithms, when they expose to more and more amount of a data, you will find their performance become flat after some time. So what you realize that after some time, even if I provide large amount of training data, I will not find an improvement in the performance, and which is not acceptable. As a human being, what we want is, if I'm giving you sufficiently large amount of a training data, what I want is absolutely highly, accurate algorithms to come. Unfortunately, your machine learning algorithms will saturate, and after some time, you will realize that giving more data is not helping you out. So that is one thing which is stopping, the popularity of machine learning algorithms. So what you have another subfield of machine learning which is called as deep learning, and it's a hot era right now. And Again, you have to go to the basics of neural networks to understand that stuff. So the beauty of deep learning algorithm is right now what people have thought is if you give me more amount of data, you will definitely get better performance compared to machine learning algorithms in the deep learning. So another reason why deep learning is becoming popular is because getting more data. And now you see, because of this high-speed internet, we are generating lot of data. And if you want to analyze that kind of a data, that scale of a data, your machine learning algorithms are not sufficient. And the good thing is that now you have a new technology called deep learning, which says that if you give me more and more data, I'll give you better and better performance. And you know, there is also limitation, right? After some time, you'll see that this curve is flattening, and you never know. After a few days, you may find another technology which we'll call as a deep learning or something new. But right now we are here, and a clear-cut advantage saying that if you have a huge amount of data, you can definitely consider going for the deep learning algorithms in order to give the better performance. So where do we see this kind of an applications right now? So where is artificial? I just gave you an example of Google Maps and other stuff. Right? So in 1954, John McCarthy, okay, in one of the mathematical conferences, he has stated these lines. And I really like that, how visionary that person was. In 1954, this guy said that an attempts will be made, somebody will do it, somebody will try out. Attempts will be made to find out how to make an abstraction and how to solve kind of a problems which are now reserved for humans. So nice. So what that guy said is attempts will be made to solve kind of a problems which are reserved for humans. So many things right now also when we're discussing, you know, these things can't be done by machine. These things are supposed to be done by human beings. We are experts of that. Machine can't do that. But in 1954, he said that, you know, attempts will be made to solve kind of a problems which are currently reserved for humans. And the first glimpse of that, which was seen in 1997, when we saw that IBM Deep Blue defeated Grandmaster Garry Kasparov. Okay, so if a machine can beat Grandmaster in the game of a chess, we first thought that, oh my God, AI is now actually coming. But if you see this, that was the chess playing machine. This is not an AI. And that is very important. So when you talk outside, you be like a technologist. Don't talk like a salesperson, right? There is something exciting. That doesn't mean there is an AI. So if you ask me, there is no AI behind. It was a great algorithms which had a very fast computing, like 30 custom CPUs, which can process 20 billion moves per minute. The code was written in structured C++ language. It was not an AI, it was chess playing machine. Though it could defeat Garry Kasparov, but people say that, okay, this was the first event when we saw that artificial intelligence is defeating humans. In 2005, there was another very nice event that is called a self-driving car. On the left, you can see that self-driving car. And this is the dirt road, which has 132 miles, okay? And this car actually covered that 132 miles without driverless car. And this work is done by Stanford AI Labs. And you will find that the founder of Stanford AI Lab was John McCarthy, who said in 1954 that attempts would be made to solve kind of a problems which are currently reserved for humans. So we thought that, you know, driving a car is a human's job. How can machine will do it? Yes, attempts are being made. Again, if you see that nothing special, it was still a computer science. Everything was pre-coded. The only good thing is that now you have sensors. If you see the definition of AI, the first thing was sense. Can you sense your environment? So cameras, radar, lasers, GPS, and many more systems, they could sense the environment. And addition to that, with a very good computing, they actually did that. So no AI involved, nothing. It was simple computer science. Now, in 2011, when IBM Watson supercomputer destroys humans in jeopardy, this is an event where actually we saw the glimpse of AI. I hope everyone understands what this game of jeopardy is. It is like a KBC. You can see that these are the two human experts, and there is an IBM Watson machine sitting over there. Question was asked in natural English language across different domains. So look, the kind of complexity that Watson supercomputer handles. The question was asked in plain English. That system understands the questions and finds the answer and fires the answer faster than human beings. That kind of a system that we saw in 2011. And here, the first time we saw machine learning, decision trees based algorithm were used. We had a big data in memory clusters. 4 terabytes of data includes entire Wikipedia data that was consumed to give answers real time faster than humans. It is fantastic to watch. So if you have a time, go on YouTube and have a look at this video, how Watson supercomputer defeat human in jeopardy. So here we start seeing the power of machine learning in 2011. 2016 is an event where Google's DeepMind defeats world's #1 game, Go. So Lee Sedol is a master of Go, and Go has much more complexity than game of chess. And this is an event where we actually saw deep learning came into the picture. And when this question was asked to Google's AlphaGo team that how you defeated Lee Sedol, amazing statement given saying that it is not just an expert system, it has no handcrafted rule. Instead, it uses machine learning, activates a deep learning technique, which figure out itself how to win the Go. And this is what the key. Please try to understand, we are developing systems which figure out itself, which figure out how to do that. So I don't know what are the next sections in this faculty development program, but when you learn neural networks, you will realize that the structure of a neural network is not changing. What you are changing is an input data, that's it. And then your system figures out how to solve the problem. So figuring out itself how to solve a problem is the beauty of deep learning. And that's the success of AI. You know, you don't code for every new problem. You just have a structure ready and system figures out itself. And that's the beauty. Okay, and that's why AI is very exciting and we are seeing amazing applications of AI. So figuring out itself is a key. Just remember that. Where else do we see that? So I hope you must have seen this very exciting application saying, now machine can generate handwriting. So we thought that, my handwriting is unique for me. That's not the case. If I have a lot of training data, I can train a system and then, a machine can write the way you write. Okay, so it's like actually handwriting by machine. This is a solved problem now. Twitter bot. So we thought that we write Twitter post and writing is it is reserved for human, but that's not the case. Now there are bots which produce the text which is very similar to humans, and it's very difficult to even figure out whether the text is written by somebody or it is written by machine. And you will find a lot of Twitter bots now. Deep brain. Picasso was a great painter, but he's not with us. But that doesn't stop us from getting the paintings like him. Okay, so deep brain. You can have a machine generated paintings. There was a fantastic story that the first machine generated painting got sold in a painting exhibition, and very experienced and talented people who have a huge domain knowledge. That lady who purchased that painting, she was completely confused and she was not knowing that this is not drawn by human, it is a machine generated painting. That's kind of a beauty that machines are generating now. Image colorization, you pass a black and white image, machine understand what is there in an object, and machine fills the color on its own. So coloring is learned by machine. Image capturing, you give a photo, machine will give you what is there in an image, and then you will find exciting applications like for a blind people, you can have an AI application, and a sound can be generated for them, right? And real-time car. So the list could be endless, right? So machine is generating text, machine is writing novel, somebody actually took Shakespeare's knowledge to be and not to be. And if you see that, a machine is also generating text like that. So if a machine can do so much stuff, can't a machine code for you? And yes, this era is coming, and I'm seeing in the software industry that hardly we will be needing software developers now, because you just write, this is what I want, and machine will write code for you. I have already seen in manual testing and automated testing how AI is automatically generating new test cases. So currently, if a human being is taking 10 days to write test cases, machine is doing in few hours. And we have already seen that this is happening in software industry. So the big worry everybody is having is, will machine take my job? So will AI replace me? The short answer is no. The thing is, because it is important for you to learn AI. Once you learn AI and other systems, you'll understand why it is difficult to replace humans. When this question was asked to Andrew Ng, he said that worrying AI will take my job or AI is threat, it's like worrying about population problem on Mars. We have just sent one satellite on Mars, so just don't worry about there would be a population problem on Mars. The AI algorithms, the systems are not at all mature right now. So rather than considering AI as a threat, what we should all agree saying that it's not a competition with machine, rather than it's a collaboration. And the moment you start in a working in a mode of collaboration with machine, it's fantastic. Now you will find that in how many tasks machine will help you, how machine can improve your life, and overall how machine can help for mankind. So this is how, so we will be discussing everything in this spirit of collaboration with AI. And let's get started about how this collaboration can be done and all that stuff. So before we move to this, and I know it's a 2-week course, I'm sorry, I'm not knowing the contents of all the sessions that we will be having for next 2 weeks, but I'm sure there would be very exciting applications and everything. So before we move there, it's very important for you to understand some of the basics of machine learning. As I said, machine learning is a subfield of computer science. So in this session, I'll just brush up some of the basics, bring everybody on the same page, so that when you attain the next lectures, you will understand what I'm saying. Sure, the eminent speakers who will be coming, they will be also having very limited time, and they may not go to the very basic things, but it's very important for you to have a clear understanding of the things. So let's get started with a very traditional programming paradigm. So how you currently do the things. So you have inputs. So whenever there is a requirement, whenever there is a problem, you have inputs with you. And as a programmer, you understand what is to be done and how input look like. As a programmer, you go ahead and you write a program, and then you feed this program to computer. And the job of computer is to generate output. This is what we do every day. Now my question is, what we do if we do not like our output, if we are not happy with our output, what we do? So if we do not like about our output, what we do is we go back, and what we do from here is we go back as a programmer, and we repeat this cycle again and again, right? So the thing is, in outside world, people call that what we do in the big IT companies and tasks, what we do is all automation. But if you see the traditional programming paradigm, it's a person, a programmer, who understands what are my input, what is my requirement, what is my problem. Based on that, this programmer manually writes the program with his knowledge in a different kind of language, and it gives this computer to execute. Now, please understand, computer is just a dump machine. Okay, it doesn't understand anything. It executes a program written by you and generate an output. It's your responsibility to understand whether this output is correct or not. If this output is not correct, it's I got some network fluctuation here. Can somebody give me a feedback? Am I audible well?
Yes, sir. Properly audible. No problem, sir.
Hello?
Yes, sir, you're audible.
Hello.
Okay, thank you so much. Yes, thank you. Okay. So it's programmer's job to understand what's wrong with my output, and he comes back and he writes the program. So for the sake of declaration, we say that we are doing automation, but if you see this philosophy, everything is done by human beings, but we still call it as an automation. Okay, the only automation part is your program is executed by this machine. That's it. But whole intelligence lies with this person called programmer. In machine learning, the things have changed. The very fundamental difference in machine learning is inputs and outputs are both given to computer. So what we say that, hello computer, this is my set, these are my sets of input, and for that particular sets of input, these are my corresponding outputs. I am giving you both input and output. It's your job to figure out the relationship between them, and you come up with a program. Very fundamental difference between these two things is in computer programming, we were writing the program, but in machine learning, computer writes a program for you. And this program is called as a model. And this model could be simple model like a decision tree or logistic regression, anything else. But the beauty is finding out the relations between input and output, finding out the rules. We don't do that. That is done by machine. And that's why we call it machine learning as an automation of automation. So if just writing a program is an automation, sorry, if just writing a program is an automation, then what we are doing, we are automating that. And that's the fundamental difference between computer programming and machine learning. It's very important for you to understand this. So I don't know how many of you have an experience of doing actual coding in machine learning. If somebody of you have tried scikit-learn library, you feel that the syntax is also similar to this philosophy. What is your syntax? If you see this, it's model.fit. You actually do that model.fit and you write x comma y. That's the Python syntax that you give. Model.fit x comma y. This x comma y actually saying that x comma y. Input and output, I'm giving you both. And it's your job to fit them together and return me a model. That's the philosophy of machine learning, right? And in a typical terms, now I'll not cover entire theory. I know we have a very limited time, but again, unless and until these terms are not clear, it's very difficult for you to grasp the next complicated sections. So machine learning, typically the algorithms are divided into three categories: supervised learning, unsupervised learning, and reinforcement learning. A typical supervised learning philosophy is like this. Right answers would be given to you, and your job is to produce more right answers. And most of an application, you will see that they fall under this supervised learning, where you have a very nice training data. And now, if we align this discussion towards biomedical engineering, healthcare application, you'll see that there is a huge need for developing fantastic supervised learning algorithms, because especially in the domain of healthcare, we live in a country like India, where there is a scarcity of experienced doctors, right? And we have a huge population, and a lot of scans and CT scans and other devices are done, but we don't have experts to see those images, right? So supervised learning philosophy can be used, saying that I have this lot of training data, experienced doctors have done their diagnostics on the images that is saved in their clinical notes. So I have medical images and the doctor's impression written on that image. So you have input. The input could be anything. Input could be your biomarker data. Input could be your medical imaging data. And the output is a text that is written by the doctor. And then this fits very well in supervised learning philosophy, saying that I have a humongous data. Now let me train my algorithm in a supervised label. Supervised stands for you have a ground truth data available. And once you have that X comma Y, X as an input and Y as an output, once you have both, you will train supervised learning algorithms, and then you have a model. And why it is model? Model is not, so you don't have exact replica of a doctor, but you can model the behavior of a doctor. And for a new patient, you can generate the outcomes which are very similar that what model doctor have done, right? So supervised learning, as I said, right answers are given and you need to produce more right answers. Very much applicable in real life applications, especially for biomedical and healthcare. Lot of data already available, but unfortunately, people are not consuming it. So if you want to pursue your career in this domain, it's an fantastic area, because as I told you, I work a lot in medical healthcare and imaging, and I understand that there is huge scope to develop algorithms, and that too for the country like India. Money is another aspect, but you can have we will discuss more about while discussing an applications. But that's what supervised learning is all about. We'll go a little bit deep after some time on this as well. If this is supervised learning, then what is unsupervised learning? In unsupervised learning, the data is not labeled. And if you are in academia, if you are doing your PhD research, if you want to publish some papers, you would obviously most of the time you will be working in the supervised learning domains, because you want to show that how AI is performing better than humans. And in order to show that how it is performing better than humans, what you need is a human annotated data. So they can say that, okay, this is what humans are doing, and this is how machine is doing. But if you work in an industry, you will find that we interact with a lot of our customers saying that we want to apply AI and machine learning. We have a lot of data, but what they say is our data is not annotated. Means is that we have a lot of data, but label is not there. Data labeling is not done. And when there is no label available, when your data is not annotated, the supervised learning cannot be applied, and then you come into unsupervised learning domain. We will discuss what can be done in unsupervised learning. And the last but not least, and very important, is called reinforcement learning. And in reinforcement learning, the situation is, you always have an agent, and that agent interacts with an environment. And you're continuously in a domain of improvising the thing. So there is no explicit training data as such, but you define the policy, and for every action taken by agent, you evaluate the cost of it. Okay, so if agent is not doing good, there would be a penalty for him. If agent is doing good, you will give a reward. So there is a penalty function, there is a reward function, and based on that, your agent learns to perform. That's the philosophy of reinforcement. So this is again, I said it's unfair to cover the things, but we have limited time. But I think it is important for you to just brush up these concepts. So in supervised learning, typically in machine learning, you'll see that there are two types of algorithms. One is called regression, and another is called classification. In the regression domain, your job is to predict continuous value. So when I say continuous value, the applications could be, you will be predicting what is the salary of an employee, what would be the temperature. So when I say what would be the temperature, it would the numbers that you would produce would be like 33, 35, 42. So this is the continuous output. Okay. If you are working in healthcare domain, right, currently we are working on predicting survival analysis for chronic kidney disease patients. So if you are predicting the value of a creatinine, then the value of creatinine could be like 0.8, 0.9, 1.5. So this would be an output of your algorithm, which is in the continuous domain. So if your job is to predict this, you will be using regression algorithm, and there are different further algorithm in a regression domain. On the other side, if you're working in a classification mode, rather than predicting continuous value, you would be predicting the classes. For example, the job is to predict whether the tomorrow or the next week would be a hot day or it's a cold day, right? So it's a hot and cold prediction requirement. You are not actually expecting to give the numbers in real time. In terms of survival analysis, your job is to just give your numbers saying that whether the patient will survive or patient will not survive, right? So these kind of a problem will fall under the classification problem. Again, both are supervised learning, because what we want to know is we need an historical ground truth data. In what cases patient died, in what cases patient survived. Give me a lot of training data. I will give it to machine. Algorithm will figure out the right pattern, and I'll have a model ready. That's the philosophy of typical supervised learning algorithm. In unsupervised learning, as I said, the first problem is that in many real life problems, we do not get labeled data. So if I do not have a labeled data, what I'll be doing is, if this is my data and if the labels are not there, so I don't know which of these patients are having cancers and which of the patients are not having cancers. This is my dimension 1 and this is my dimension number 2. Then I'll apply clustering algorithms to group them together. And once I group them together, then probably I'll apply some more investigation on different clusters separately. The very interesting applications of clustering in biomedical domain is actually to find the patient cohort. For example, if I want to do some kind of a clinical trial, I want similar type of a patient. So imagine I'm having huge data set of say 100,000 patients, and I have a clinical trial prototype ready, say COVID-19 vaccine for a particular type of a people. What I want is, I cannot give this kind of a drug to all these patients. So what I do is apply clustering algorithms. I create small clusters in such a way that all the patients in one particular cluster will have some kind of a similarity. So if I'm having diversifying understanding of all the races, all kind of a patients, what I'll do is, after doing clustering, I'll few patients from different clusters, and then I test my vaccine. So to claim that, it works for all kind of a patient, right? If I randomly choose that, it may find that you will get all the patients with Asian race and black skin color and having a diabetes, then you won't get real picture what is happening. So this clustering is widely applied in healthcare, and the good example that I gave is the patient cohort identification. Anomaly detection, fantastic area. Again, you don't have label data for this. What you have is a data, and you want to find anomalies into this data. Finding an anomalies is very important. The very good application in general domain is identifying frauds, credit card frauds and other type of stuff, where you will find that all your transactions are good, but there is something new, and you will catch it saying that, oh, this could be a fraud. You can create applications like network intrusion detection in cybersecurity. This is how typical the transaction happening on my server, but something new came. You will highlight saying that this could be an attack on my system. So in all those domain, anomaly detection is heavily used. And dimensionality reduction it has obvious advantages of saving memory and visualization, and very interesting application that you see in theory is called PCA, called principal component analysis. There are algorithm as TSNE. So beautiful stuff is there in this Riemann-Schur reduction. They all come under unsupervised learning. I hope you must have learned or heard some of these names. The next stuff is called reinforcement learning. As I said, this is an agent and this is an environment. So agent is continuously changing its state, getting a feedback from environment about what action agent is taking, and based on the reward function, you will actually learn to do good things. Again, figuring it on its own how to solve the problems. The very interesting example of this reinforcement learning is playing the game of a chess. Suppose you want to create a program which is playing chess against human. You can't say that, no matter how opponent is playing, my next move would be always this. Your next move is always dependent on your environment, how your opponent is playing. Based on how your opponent is playing, you will decide what would be my next move. And what is a reward? The reward is, moving forward. Converting all your pawns into queens is a reward. You have to move forward. And obviously, you have to prevent the damage. You have to save your pieces. So defining the right reward function, you can actually decide how to win this. And you know what? I'm actually working on the beautiful project here on the reinforcement learning, and a very interesting application called liquid handler optimization, where the blood samples are taken by robot, and there are too many settings to be done on the robot. And if those blood samples, you're not allowed to miss it. So there are too many settings that to be done on that robot in order to get the best performance on that. Obviously, not everybody is expert to do those kind of settings. So what we do is we put a reinforcement learning system, and the agent actually recommends what kind of settings to be put in order to prevent the loss and eventually the money. So that's how reinforcement learning goes in real life examples. So what we learned so far is machine learning algorithms, and I'm showing you on a screen some very, very popular machine learning algorithms that you will study in your syllabus, you will study on online courses. Rather, I would say that these kind of a must to know kind of thing. If you are doing AI, you must be knowing this. You will learn regression, you will learn random forest, KNN, K-mean clustering, support vector machine, anomaly detection, naive bias. So these are the very popular and well-known algorithms. Now the problem is that if you finish your online course on Coursera, or if you learn from some other way, after knowing this, people feel that, oh yes, I have understood everything. I know machine learning. But if you feel like this, what you know is just a tip of the iceberg. And what you need to know is a lot. Even in machine learning, if you see that there are too many machine learning algorithms, if you see that what you know is naive bias from here, decision trees from here, PCA from here, KNN from here, logistic or regression from here, some kind of regularization here, and what you know is random forest and other stuff, right? But real machine learning, if you see that the list is exhaustive, and every day new algorithm is being added because there are too many researchers developing their own algorithm, and this list is just piling up. So the one way is like you can keep on learning all those together, which I don't think so is the right idea. Other way down is to learn or to work on areas where really there is a need, because you can keep on adding new algorithm to this list, and your one particular algorithm can perform better than all algorithms in the list that I have shown you on one particular data set by a margin of 0.001, right? And the moment you change your data set, you will figure out, no, other algorithm is performing better than that. So either you spend your energy learning that, or you can learn some new exciting things. Actually, there is a blocker where actually there is a need to develop something new and exciting. Why there is a need? Please understand that. If you finish your course on machine learning, if you understand machine learning very well, you'll see that all machine learning algorithms need the training data in this structured format. You will have your target variable here called y, and you will have your training features like x1 and x2 and x3, blah, 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 up to xn. Every machine learning problem that you have worked so far, or you will be working so far, you will figure out that the very fundamental requirement of those kind of an algorithms is to have a structured data like this. You'll see that people share their data sets in CSV files. If you go on Kaggle, it's all about sharing those CSV files and everything, right? So machine learning needs data in the structured format. Not a single machine learning algorithm will work without this. So what's the problem? The problem is real life problems are not structured problems. Real life problems, the real life data that we'll get, it will be always in unstructured manner. If you want to work in exciting domain like image processing, it's an unstructured data. Voice processing, speech processing, speaker recognition, signal processing, vibration analysis, earth signal analysis, gravitational waves, heat waves, all the data is in unstructured format. Huge amount of text is being created, clinical notes, patient notes, Twitter data, Google data, search query data, everything is in unstructured text format. So the very exciting applications of AI that I've shown you in the figure, unfortunately, the nature of that data is not structured. And if the data on which you are working, if it is not structured, not a single machine learning algorithm can be applied on the top of it, right? So after doing an ML course, your situation would be something like this. Even if I learned ML, I'm not able to solve the real life problems, or exciting problems. So what you will do is, you will go back to machine saying that, will you help me to extract features as well? Because my data is not structured. Can you help me to extract the features as well? Machine says that, why not? I just need to see deep into it. And that's why the very important reason for learning deep learning is this, that the data is not structured and I still want to do some kind of training on it. So why deep learning is popular? The second reason, or the second big difference between machine learning and deep learning is this. You have, in machine learning, you need somebody to write a code. Now this is a manually written code to extract features, and then you can apply your algorithms here to get the desired output. But the beauty of deep learning is you can throw your raw data. The raw data could be direct image, direct audio signal, a direct vibration signal, direct time series signal. And this deep learning stuff, what it will do is a very important stuff of doing feature engineering. Extracting features is done by machine and you get your output. And that's why you'll see that if you see new generation data scientists, I remember there was a talk a few years back in a conference, and the speaker says that I can see your code and I can figure out what is your age, because old age traditional data scientists, they used to spend huge amount of a time and energy to extract features on their own. Lot of feature engineering, lot of custom features, lot of derived features, exhaustive coding that was implemented, and then they designed our algorithm. However, the new generation technique, And the new generation data scientists, they are using deep learning and saying that, hey, why should I spend my time in feature engineering? Let machine figure out what is good. What features are important, not my job. It's whose job? It's machine's job to extract that. And that's why deep learning is very elegant. Okay, so that's a fundamental difference between machine learning and deep learning. So now let's look at some of the basics of uh, deep learning. Again, it's unfair to cover basics of deep learning uh, in a very short duration. But what I'm telling you is, I'll not be teaching you the basics of deep learning. Maybe sometime else. But I'm telling you that what you must know. So if you have not studied yet, what I would recommend is to the topics that I'm going to show you after these slides, better you quickly revise them, at least get those concepts clear before you understand, before you attend the next lecture series for this 2-week course. Because if you don't know these terms, you will not really understand what the speaker is saying about, what kind of algorithms he is talking about. Okay? Basics of deep learning, I'm going to tell you a few things that you must be knowing about it. Okay, so very first thing is about you should be knowing the fundamentals of neural networks, how a typical neuron work. These are your input, then you have a summation, and then you do an activation function, and then you got an output. So what you need to know that how a simple neuron work, like simple perceptron, and then how this neural network works. Again, I'm saying you do not open the old books and don't consider that this is like, oh my God, we had this neural networks in our graduation syllabus, but we know how difficult it was, so we did. No, it's not. You know, the things are not very difficult. You know, the things are very simple. Please understand it and get your concept clear around fundamentals of neural networks. Then only you will appreciate deep learning and other applications. Okay. So learn this algorithm called gradient descent. You understand that the fundamental rule is always W new. The new weights is equal to old weights minus alpha times dj by dw. This alpha is your learning rate. These are your old weights, and these are your new weights. You'll find that all the algorithms that we use, they will be having the fundamental variations of a very basic rule. W new is equal to W old minus alpha times dj by dw. If you understand this very well, then you will understand, how actually a learning process happens. And then you will understand the complexity of the problem also. And then you will understand, the real stuff of deep learning, and how then also you will be able to figure out then why, even though these algorithms were ready in 1960s, but why people couldn't train it. And now in 2020, you have free GPU available, and how you can nicely create an applications by using Colab and other stuff. But in order to appreciate all that, you should understand how gradient descent works and why it is needed. What is the philosophy of developing this a very nice looking formula called W mu is equal to W old minus alpha times dg by dw. Again, as I said, I'm not going to teach you the basics now. This is not right time. But what I'm telling you is learn this. Okay, you must know how this definition came and how weight updates are happening. What do you mean by gradient descent? What is local minima and all that? This is important for you to understand, how actually optimization happens and what is an effect of learning rate alpha, how it should be set. So these are the things I believe are prerequisites for you in order to understand the upcoming lectures, because I don't think so anybody will get time to cover that level of details. So today you can quickly open your books, open some tutorials, and get those things clarified if you don't know yet. And obviously the back propagation. Okay, so what you need to know is simple fundamentals of neural networks, gradient descent, and obviously a back propagation. So this we have learned in our 12th standard partial differentiation and chain rule. That's how the back propagation works. Cool. So once you know these many basic things, you will be ready to start with your exciting journey of deep learning. Again, you don't have to manually solve those complicated mathematical definitions. You are having a lot of exciting deep learning frameworks. The deep learning framework called Caffe. Caffe is one of the oldest deep learning framework. And you know, the framework is designed by students of University of Berkeley. Unfortunately, now nobody uses Caffe, but the it is taken by Facebook, and soon you will find that Caffe 2 will come, and this Caffe 2 would be revolutionary. Microsoft has its own framework called CNTK, Torch, and Torch, the basic version of a Torch was designed in a programming language Lua. I don't know how many of you have ever coded in language Lua. To be very frank, I have never done even Hello World in Lua, and there are many programmers like me. So initially, people, they don't appreciate Torch first. Looking at the popularity of TensorFlow, Torch understood that sticking with a programming language called Lua will not help us. If you want to gain a popularity, you have to shift to Python. And now Torch has their own version called PyTorch. And this PyTorch is now competing with TensorFlow. And there is a big fight between TensorFlow and PyTorch. And people are saying that PyTorch will move forward, but TensorFlow has a backup with Google. It's your choice. Piano initially, it tried to compete with TensorFlow, but popularity of TensorFlow was so high, eventually Piano died, and they say that, okay, we are not in a competition now, and they closed, say that the project is shut down. Keras is not a pure low-level framework. Keras is a wrapper written on TensorFlow. So either you can have a coding in TensorFlow directly, nobody appreciates that. I don't know whether you have done coding in TensorFlow. Nobody actually in industry does coding in TensorFlow. We all do it in Keras. It's damn simple to do. But rather than having TensorFlow in the backend and having a wrapper of Keras, if you don't want to have these two, you have a PyTorch. And there are many more advantages of doing it PyTorch. It's difficult to call. So far, I'm with the combination of TensorFlow and Keras. I'm not getting time to upgrade myself to PyTorch. But yes, it's interesting. People are moving towards it. Personally, I have not done that. But eventually, my recommendation is, stick to one stack. Either you be with Keras, TensorFlow, or you start your journey with PyTorch. Okay, so that's all about frameworks. The bottom line is, the bottom line is, you don't have to do that math on your own. You have this fantastic frameworks. You just need to write some Python code and they will do all that math for you. But being an academician, researcher, you should be knowing what is happening in the back. So I don't recommend you to, blindly call those APIs, rather understand what is going on in the back. So that's about the deep learning frameworks that you have. So let's understand some of the steps. So like in machine learning, we have a lot of algorithms. In machine learning, we have lots of algorithms, right? In deep learning, we do not have a lot of algorithms. Rather than what we have is a lot of architecture. And what I'm showing you on a picture is a very fundamental architecture of a CNN. The beauty is that, as I said, you can throw the raw data as it is, so you don't have to spend your energy on extracting features on it. You can throw image as it is, and then you have a very nice convolution block here. So you have convolution and ReLU pooling, convolution, ReLU pooling. They will extract features for you. Now, I hope you understand what this means, and it should not be too high level. Let me quickly tell you that. So, in old age, image processing era, I hope you must have learned there was a book, um, I think Gonzalez and Woods. So there are a lot of kernels mentioned in that book. Okay, so typically in image processing uh, domain, people call them as a filters. Okay, so these filters, they have their some value predefined like 1, 1, 0, whatever could be the filter. Okay, and every filter has its own, every kernel has its own filter like this. So it could be an uh, uh, it could be a Sobel kernel, it could be an age detection, it could be many things. So a lot of kernels are predefined, and you convolve this kernel over an image. So I hope you understand what do you mean by convolving a kernel over an image. So this kernel you will pass from every patch of this image. So if this is a 3x3 kernel, so you'll place this 3x3 kernel on this 3x3 patch of your image. So there in the back there would be 3x3 pixels, 9 pixels of images, and this 9 pixels of this kernel. So you will take this element from kernel and this element from image. You will do multiplication. So there would be 9 multiplications and combined additions, and then you have a final answer here. So that process is called as a convolving kernel over an image. But in historical image processing theory, people used to spend a lot of energy to extract these kernels on their own. People have done PhDs in defining their own kernels. But that philosophy has gone now. This is an era of a deep learning, and what you do is, now please try to understand this beautiful concept. These kernels are not predefined. The values of these kernels are learned by machine. This is very important. If you have fundamental understanding of neural networks, you say that there is a rule called W new is equal to W old minus alpha times dj by dw, j cost. Looking at your current cost, your weights are changed in order to reduce the cost. Now this is a typical neural network structure here. So you'll not only change the weights on the layers of your neural network, you will come back and you will change the value of your kernels also. So the beauty of CNNs is you don't care what kind of a kernel to use. You just start with a random kernel and machine decides what type of a kernel. This is so beautiful, and that's why it's elegant. So you have an image and the values of that kernel would be learned, and the required features would be extracted. This part will convert your unstructured data into structured format, and once it is structured, this is a typical machine learning. That's the beauty. So this part in deep learning is all about feature engineering, and the beauty is nobody writes rules, nobody writes codes. What features are required to solve my problems, those features would be extracted by the machine. That's the beauty. Okay, I hope, I know it's not justice to CNN, but I tried to give you an idea like how it is different and why it is important. So once you know the CNN, which does the classification start, then fun starts. Now, if you are in a biomedical domain, if you know CNNs, then you can come up with these exciting applications like image classification. Now what you need is, as I said, a typical supervised learning philosophy. Suppose you want to come up with an application where somebody will upload an X-ray image and you will determine whether it's a normal X-ray, whether it's a pneumonia, bacterial pneumonia, or it's a viral pneumonia. What you need to do is you need to have a lot of training data, supervised learning. So you need to have a lot of label data, create 3 folders, one folder called normal, one folder called bacterial pneumonia, third folder called viral pneumonia, fit those images there, train a network, and then you have a model ready. So whenever a new image is given, you will have your own. That simple it is because of the power of CNNs. Again, I said, see this. if you see that there are many CNN architectures, AlexNet, ResNet, and all that stuff, you'll see that whenever application changes, you won't change your network. You can have a same network and you can change your training data and change your labels. You'll see that the same network which was performing a task 1 before is now performing the task 2. So at the very beginning of this session, do you remember I told you that Google's, they defeated Lee Sedol, saying that it has figured out how to win. So every domain, so no matter what kind of domain it is, I will have the same kind of neural network, but it will figure out to find the differences, and that's the beauty. Now the same thing you can do for, now in India there is a need, many people they have a diabetic retinopathy, and in the rural India people even don't get to see the doctor to see that there is a retinopathy. But you can create an application, like click an image by cell phone, let that image go to server, and it will tell you saying that, oh, this person is having retinopathy or not having retinopathy. You can create all sorts of applications like this. Now, this is a typical application for detecting skin cancer. These are the different types of skin cancers. What you eventually need is a lot of training data, and that too with annotations with it. If you have, you can do that. So, to be very frank, everybody is doing this kind of an application. Okay, so this is about image classification. Another type of AI, what you can do is about object detection or segmentation. So what we saw here is about classification problem, but in this is called as a detection problem. So this is this is a CT scan image, and this is a lung nodule. You want to detect a nodule, or this is an MRI, and this is a brain tumor, and this is the same. So understand that this is again a supervised learning philosophy, but the way in which you create your training data is different. So this is my input image. So you can say that this is my input X, and this is the output image Y. So what I want is everything is black and this tumor should be highlighted. So if you want to come up with this kind of an application, you should have annotated data like this. So please understand that. Okay, so nothing has changed. Okay, only thing is if you want to come up the application like this, it's like a encoder decoder kind of an application where you will train a neural network saying that my input is image, like this. So when I give this kind of an image, this is my neural network, it should produce image like this to me. So this is again supervised learning. I'm saying that I know input and output. So this is the input MRI, and this is the segmentation done by the doctors. And I have a lot of images like this already available. What I need to do is I want to train this neural network. I'm saying that when I give this input image, network should produce this. Obviously, initially the weights in the network will not be trained. So when you pass this image, the output will not be the desired one that you want. Then you calculate the cost, and then you say that I want to minimize this cost. In order to minimize this cost, the weights in the neural network will change, and obviously your kernels will change. So the cycle of passing the training data, finding an output Y, then comparing it with ground truth Y truth, then finding out the difference, calculating the cost, and then applying back propagation. This will go on. So if you understand, the philosophy is same. What you need is nicely annotated data. And then people are doing some exciting innovation, saying that, oh no, this encoder decoder is not working well. So then people have come up with a structure like this. So there is a lot of encoding, decoding like this. Again, input is an image, output is an image, and the network is called as a UNet. And then you'll find out there is a UNet, then VNet, and a lot of variations coming up. So sky is the limit. Tomorrow you can come up with your own network, give a beautiful name. As far as you are producing results better than somebody else, there is a scope for publication. And that's how the things are moving so fast. So this is about object detection, segmentation, and biomedical images. So this is another project. I'm working on it. It's an exciting project. What I'm trying to do is I'm talking to one of the leading radiology companies, saying that we can automate your entire radiology workflow by using an AI. Okay, so what you need to do is you just update your X-ray image here. Then by AI-enabled diagnostics tell you what kind of diseases the person will have. It will generate a text that how typically a radiologist does. Again, this is machine generated text. Okay, nobody is writing that. So by looking at these images, this text would be generated, and from this text you will find that there would be an NLP called entity extraction, saying that out of this, what is the problem. So once I'm having analyticity on it, you'll see that there are a lot of applications coming up. So that's how interesting that application can go. Again, everything is supervised here because I am having a lot of chest x-rays available and lot of radiology reports available. So if I know image and its corresponding findings, I can train this and I can generate the findings if image is given. Once I know this text, I can do entity extraction on the top. Once I know X-ray and what are the diseases identified, I can still call it as a supervised problem. Okay, so this kind of an applications, people are developing an industry, and you will find there's a huge scope for these applications. And then a lot of publicly available data is there. So nobody is now, nothing is stopping you from coming up with exciting applications. What you need to know is some fundamentals, some access to compute, and willingness to try out new things. So like there is a lung nodule, so you will find Luna 16 data sets are available. Annotations are done by doctors, and you can create very exciting applications. Something like this, you upload the CT scan image, and it will detect the nodule 1, nodule 2, nodule 3, and it will predict this parameter. And very importantly is, human interpretable explanation whether the detected nodule is malignant or benign. So these kind of an applications, you can develop and people can use that. In the pharmacy, so biology is a domain where, lot of AI intervention you will find that, because these people, they take the microscope and observe this image manually, huge amount of data, very tedious stuff. And if you ask me, eventually it's all about image segmentation part, right? So let it be an detecting a region of interest, nuclei segmentation, or epithelium segmentation, tube segmentation. For you, it's just an application of UNet. Then you can have a lymphocyte detection like this, or understanding what type of lymphoma it is, and numbers per region and counting. So all these are the typical applications of AI in biology. Now the question will come as like, oh, if the things are so exciting, how should I develop AI applications? So if you want to develop AI or machine learning applications, you typically have these three options with you. There are a lot of frameworks and libraries available. There are some cloud platforms, and there are web services available. Web services typically are like IBM Watson, Google Cloud AI, and Azure. The good part of this is you don't have to learn AI. These are all managed services. You just upload your data and they'll get the things done for you. And there are many startups which are coming up in domain. So what they do is they find a one domain, they collect a lot of data and create very accurate algorithm, and then they release their models in terms of service. So it's like pay as per use. So you can quickly develop an application by calling those services. It hardly takes 2 minutes for you to integrate those services. The limitation of this is you do not have any control on accuracy. Second is you have to pay for them. That's it. And the advantages, they are very fast. So either you can use those services or you can use cloud-based platforms. So cloud-based platform says that, as I said, you have no control on accuracy. So mid option is, you can bring your own data on their cloud. So you can pass your data on their cloud, and then training will happen on cloud. Good thing is that they claim that you don't have to worry about, you just give us your data and we have algorithms to figure out for you. So there is a new philosophy which is coming up, which is called as AutoML. AutoML says that we will tell you what algorithm is good and what parameters are good for you. So the data science job is also getting automated by AI. It's a driverless AI. You put your data and we will train it for you just by a single click. Advantages, again, you don't have to learn math and all that stuff. These tools will do it for you. They are fast, they are accurate. But disadvantages, security is a concern because you cannot pass your data to the cloud if the data is secure data. So security is compromised. And again, the services are paid. But again, based on your application, you can decide which path to take for. But this is also option available for you. My recommendation for you is you should go for libraries like a frameworks that we discussed, and then because you have full control, they are open source, they are free, you have fine-grained control on each and every parameter. So what you need to do is right from data pre-processing, data learning, evaluation, and prediction, all those steps you will have to do on your own. The advantage is you have full control on your application. Disadvantage is you need to know all those modules, but I don't call it as a disadvantage. I call it good. That should be an inspiration for everybody of us to learn AI and understand algorithms and how to do the thing. So this is the recommendation option, especially for people in academia and the students in industry. We do not have time. Sometimes our customers, they pay for us for the cloud services. So we take that option, but this is the one that I will recommend for everybody. So growth drivers in AI in healthcare. So in biomedical and healthcare, you'll see that healthcare expenses are really high. You have a population problems. You have a very limited healthcare professionals. So all that actually driving the growth of AI in this field. There are some potential challenges. Obviously, you need development cost, you need to have integration issues, data privacy are the concern, data exchange problems, and these are the typical potential challenges for developing applications. Future Indian scenario, what I see is there would be a lot of collaboration with medical and technical institutes, which is already happening. And in the COVID situation, we have seen that many technical people, they actually collaborated with hospitals in order to optimize their processes, optimize their ICU consumptions, and obviously diagnostics applications are coming up. Government is providing a lot of fundings to come up with AI applications in India. So AI for India initiative is very exciting. The another problem in India is, the data that is stored. So we hardly have a well-organized digital version of this data. So that is one of the blocker, for applications of AI in Indian scenario, but the things are getting improved and I could see a bright future for here. The good thing is, as I said, we have huge populations, so a lot of data, and we have scarcity of doctors. So we definitely need AI to help in healthcare and biomedical domain. Now, I will take a small pause here saying that this is how introduction to AI is, a lot of exciting stuff that you need to do here. And obviously for next 2 weeks, you will be learning a lot of applications of AI in full depth. So I wish you the best of luck for those sessions. I hope you enjoy all those sessions and learn a lot of things. And in all those sessions, you will feel that at the end, people will see that how accurate my model is, because the whole effort is to design accurate models. And I'm saying that accuracy of AI models is undoubtedly the most important factor, However, only accuracy is not enough. So responsible AI is a very important factor. So I think, we will be meeting soon again on 5th of December, where I'll be talking about why only accuracy is not enough, what are the real life challenges to deploy AI applications in industry. And these are the typical pillars of responsible AI. And each pillar is like a wide open research problem for you. So with that, I think I'll take a pause here. Hope you like today's sessions, and best of luck for next 2 weeks. And I hope you will learn amazing things. Yeah. So that's it from my side. Over to you, ma'am.
Yes, thank you. Thank you very much, sir. Am I audible, sir? Yes, Kulkarni madam?
Yes,
Yeah.
very well.
Yes, ma'am.
Thank you very much, sir, for this informative session. I have few questions. Can we proceed for it?
Yes, sure.
So as you have shown in your presentation, the number of algorithms,
Yeah.
means the vast range is there. So how the new learner how to start?
So that's a good thing, as I said, whenever a new learner starts, so the goal should not be saying that, I'll come up with an algorithm which will defeat all existing algorithms in the literature. Okay, that is super ambitious goal. Okay, what a new learner should see is like, first he or she should identify the domain, find out what are the existing literature, what are existing algorithms already worked out in this particular domain. Rather than starting from scratch, I always recommend to stand on somebody else's shoulder and take a longer jump. So I don't recommend to start from scratch, but you can find the very good algorithms or approaches developed by the people, and then the whole ball game is to identify the gaps, identify where they are failing, identify uh, situations or cases or the data in which the state of algorithms are failing, and then your contribution, your delta contribution starts there, saying that, oh, okay, now let me work on this aspect. So I'll take a jump from somebody else, I'll take somebody else's base, I'll recommend some improvisation there so that it will perform better than the previous. That's the best approach I feel someone should take, because uh, technology is moving so fast and new things are coming so, there are vast amount of data and algorithms and research already available. It's hard to see that, whatever you develop is like, it's a novel and nobody has tried out that. So again, bottom line is focus on that delta improvement on somebody else. That's the best. So it's all about collaboration.
Yes. Yes, sir. Yes, sir. So this is about a new learner.
Yeah.
But as we know, nowadays students are also taking interest in AI and they want to go for the projects in AI.
Yes.
So they want actually they want expertise in AI from the career point of view also.
Yeah.
So what will be your words for this?
For the students, I would recommend them to have their basics very clear, and after having a very good clarity on the basics, they must try hands-on. While doing a hands-on, they should target to develop not only prototypes but production ready kind of stuff, because I've seen when I go for evaluation for their BE projects, I see a gap saying that okay, idea is good, but most of the time it remains till the prototype level. So if you come and understand, if you see that ML modeling is a very small part of an entire project, but it covers a big area, right from developing pipelines, getting in data and all that stuff. So I would recommend students should also focus from end-to-end project perspective apart from typical modeling. Again, at B level, it's very hard for them to come up with something new, but definitely they can master some of an areas. Don't try to do everything. If they find NLP is an area what they like, then go deep there. If they like imaging stuff, then they can work on images. But it's a very vast area. They should find their interest first and then pick a use case into that domain. Do the literature survey, reproduce somebody else's results, and then come up with their own something new.
Yes. Sir, as we discuss about hands-on, so which platform you will suggest for AI? Means whether to start with MATLAB, Python?
See, Python is more than sufficient because it's open source and free. You don't have to go for any commercial softwares. This is my personal opinion again. A lot of literature, tutorials, material, code, everything is available for Python. So for the students, it's like I'll say that it's a go-to kind of a technology stack. They can start with TensorFlow, Keras, developing in Python. They have access to Google Colab, so GPU is not a problem as well.
Yes, sir. And
Also,
last, yes, sir.
Also, I've seen that some of the institutions in Pune, I know a couple of them, for their students now they are investing in hardware. So they have their on-prem GPU systems as well, which I see helping their students to come up with a very good applications and projects. So this is how colleges and institutions, they can also help their students to have that kind of a lab setup.
Yes. Thank you very much, sir. The next question is related to the data size. So to get maximum recognition, accuracy and all that, so how to decide the size of data required for training if you're going for ML or DL?
Yeah. There is no defined answer for this. To be very, I don't have a number in mind that you need to have like 5 GBs of data or 10 GBs of data. It varies from the application to application. So it's very difficult to size it. But what I'm saying is, for the researchers, what I see is like you got to be honest with yourself, saying that if you take a very small amount of a data and train it, you understand on your own that your network is overfitting. So if you see the publicly available data sets and size, what I see like the competition, like Bragg's competition, at least 10,000 to 15,000 of images they provide for the training. That's kind of a sale is minimum what I'm talking about in terms of numbers, in order to give some kind of a decent match for algorithms to work.
Yes, sir. Hello.
Yes.
Yes, sir. So the last question is related with the PhD topic in AI. So participants would like to hear your guideline about the selection of PhD topic in AI.
Wow.
Means what type of care or what type of efforts?
What type of care, I'll definitely tell you. Choosing a PhD
yes, sir,
topic
yes,
and selective topic is it's not a short decision. Find a guide who has hands-on experience in a domain. That's a very important recommendation from my side. I have seen that people end up with defining and registering their PhD problems, which are already solved 4 years back by the universities outside. And that is one time. So be very careful while registering your PhD statement. If you ask me, again, this is my personal opinion, defining a PhD topic is more of a guide's responsibility, because at the starting of your research, PhD student is not having very good clarity and understanding of the domain. Who are the researchers? Which are the research groups? What is the state of art technology progress in that? And that's the role of a guide is important, who actually knows it. Second is, I have seen that your PhD topic should not be a development work. find some technical challenges. Do not develop an application. I've seen, if you ask me, there are many PhD problem definition, which I find, it's like an image classification problem. So what different are you doing there? So we are doing this like an X-ray classification, right? That is not a PhD topic. So if you are taking somebody else's neural network and if you are running it on the data and you are defining like 95% accuracy, it's a development work. That's not a research. So what different you did in this entire pipeline is very important. So there are many open issues there. May not be, I don't think so this is the right time to, we can discuss all those stuff. Few things that I'm already working on. And my last session on 5th, where I'm talking about responsible AI, that will open up many research topics. That is like I'll be opening up a lot of blockers. This is how we start. This is where industry is stopping. These are the open-ended things. I think that will give you a lot of idea about where current research is happening and what needs to be done. Definitely, I'm not saying. Definitely, I can say one thing. Taking a data and running on neural network and getting an accuracy. That's not a research, for sure.
Yes, sir. Yes, sir. We are looking forward for your next session. So this is at the end of our question answer session. So I, Dr. Sakshi Paithane, on behalf of Rajarshi Shahu College of Engineering, extend a very hearty vote of thanks to Dr. Bhushan Garware for sharing his valuable thoughts. So thank you very much for exploring AI, various aspects of AI, ML, and then deep learning. And definitely it has become means very informative session for our participants. Definitely they have more takeaway from this session. Thank you very much, sir. Thank you.
Thank you so much.
Yes.
Thank you, sir.
Thank you.
So participants, here we are ending our today's schedule. So be present for tomorrow's schedule. The related information will be shared on group. Thank you.
Thank you.